another possibility, and I'll warn you again, these steps are all wrong. But you might have said, okay, we know we're going to try Wallace as the username, and his password will be I like cheese. So let's put that information into a database. So insert user table values Wallace I like cheese. You know what? This is SQL code. That's probably not right. You might have said open a browser to the URL, whatever login URL. And again, that's not right. And neither of these are right because they have implementation details. And you want to avoid implementation details. There was a client I worked with once, and to their credit, they had acceptance tests. They had tens of thousands of acceptance tests. It was amazing. But their system was a DOS-based system, pretty old. It was very complicated. It was for printing stocks in the market and all this stuff. So they had all these 10,000s of tests going through this DOS interface. And they wanted to modernize, right? They wanted some Windows. They wanted something fancier, more modern. So they were going to rewrite their system using Windows. But all the information about how their system worked was in those tests. They couldn't read the code. They didn't know how exactly it worked. All the information was in those tests. Unfortunately, the tests were all going through this DOS interface, like press tab, open menu 5, go to item 6, and check this field. Very specific on the implementation of how they implemented. And so they were stuck. They couldn't rewrite it using those tests. They had to rewrite all their tests as well. So you want to avoid implementation details so that your tests can be, decoupled from the system, so that they can be usable no matter what your implementation details are. Whether your system is a web app or a desktop application or a service that's provided, your tests have to be have no implementation details so they can still work no matter what your architecture is. You can think of tests as an alternate user interface. Right? Normally we'd have a user interface which sits on top of the system, which might talk to a database, and you've got this 3-level architecture, which you see very often. Your tests act like an alternative user interface. Right? They're not going through the user interface. That's very fragile. They're going to the system. They're talking to some API which your system publishes. And it's the same API which the UI, the user interface, uses. This is the design you want to try to go towards when you're writing acceptance tests. So this might be a more acceptable form of that test script. So we'll add a user to the system whose name is Wallace and I like cheese. Process the login with username Wallace and password blah. Now those do not match these credentials, so we check that the login failed. Then we process the login again using the real username and the real password, and we check that the login succeeded. So you can see that we're building a testable environment. We're operating here, and then checking the results. We're avoiding implementation details, but yet we're being specific. We're using concrete examples in our tests. Tools. You've probably heard of these tools. Windrunner, Silk, Robot, Rational Robot. These are all amazing tools. They can drive your system right through your user interface, and lots of people use them, and they're pretty neat. However, they're not suitable for agile acceptance testing. Why not?
Too complicated to use?
They're actually pretty easy to use.
Depends on the user interface?
Yes. You need a user interface to use them. You actually need a system to drive in order to write your tests. And how can you drive your development with tests if you need a system in order to test it? So that's one big flaw. You can't write tests until you already have a system. Second is they're testing through the user interface, which is often fragile. So what came about 6 or 7 years ago is a tool called Fit. And later on, Fitnesse, which is a tool which sits on top of Fit. It uses Fit and makes it more accessible. And Fit allows you to drive development through acceptance testing. Fit stands for Framework for Integrated Tests. It was created by Ward Cunningham, and I'm curious, who has heard of Ward Cunningham? Okay. He's an amazing guy, and what's interesting is he has such an influence on the industry. Design patterns, extreme programming, Fit, the wiki. He invented the wiki. This guy's amazing, but yet only 10, 20% of people know about him. But now you all know about him, so you can take that with you. Ward Cunningham. Fit is open sourced, and it became the most accepted solution for acceptance testing on agile projects. Fitnesse was added shortly after Fit was introduced to make it more usable to the types of people who we wanted to write tests. I think I have another slide. I'll get to that. So it makes things easier. It was created by Object Mentor. Actually, what's interesting is that Object Mentor teaches extreme programming classes. And we were trying to teach all these practices like test-driven development, refactoring, acceptance testing. But acceptance testing was always a challenge. In every class we held, we did not have a good way to do acceptance testing. We always struggled with it. So we saw Fit, and we said, great, we can use this in our classes. We can use this for training. And so we started to work on Fitnesse to make it easier to write tests. We never intended it to go public, but it did, and now several people use it. Yeah.
Several. Hundreds of places.
Yeah, more people than we intended. So here's the deal. What Fit gave us was a language to write tests in HTML. HTML is something that everyone's familiar with. Maybe not the actual syntax, but looking at web pages in a browser, everyone does that. Testers, customers, business analysts, they all do it. So it's something they can look at and understand. Right? They don't have to look at code to see it execute. They can look at web pages and see that the system is working. Unfortunately, you had to execute tests on the command line. This is something that customers and business owners didn't really like doing. So Fitnesse put everything in a web server, a wiki in fact, and there's a button. You just press the button to execute the tests. In Fit, tables, every table on the page is executable. Everything else is ignored. All the text, all the other markup you have is ignored. It's the tables in your web page which are going to interact with your system and execute. This is nice because you business owners or customers can write tests in Excel. In Excel, you can save your document as HTML. And lots of customers know how to use Excel. So they can write their test in Excel, save it in HTML, and then execute their tests. There's this concept of fixtures. Right? You have your HTML, and you have your system, but you need your HTML to talk to your system somehow. And fixtures is that piece in the middle. It's the fixtures which act like glue between your HTML and your system. We're going to talk more about fixtures. What Fit adds on top of that, as I said, is a web server. It's a wiki, so you actually don't have to write HTML. You just write wiki text to write your tests. It provides a web interface, so you can just click a button and execute things. And it supports other features, like it allows you to group tests together. It gives you a place to put your tests. It allows you to refactor your tests to avoid duplication. Just several useful things that you commonly need when you're writing lots of tests. In order to use Fit, though, you need to be able to think in tables. You can't just write steps, you need to think in a table. So let's talk about that. This is an example of a Fitnesse page. And you can see here that there's lots of text. Everything in the red circle is just text, and it will be ignored when you execute it. There are some tables here. I know they're small. We'll get bigger ones in a moment. all of these will execute. So when you press, oh, there's no test button here, but if you were to execute this, all of the tables would execute and everything else is ignored. If we take a close look at one of those tables, you'll notice that every table starts with a row. This row is the name of the fixture. You have to tell Fit which fixture is going to execute this table. And the rest of the table, everything after that, is interactions with the system. There are 3 types of fixtures, fundamental fixtures, that is. You can create any custom fixture you want, but Fit comes with 3 fundamental fixtures. They're column fixture, row fixture, and action fixture. Column fixture is useful for lots of things, but maybe most importantly is entering data. So we have a table here, and it says EG division. So there's a fixture out there called division, and it's also here in Java code. So you can see the glue here between the HTML and the code. There's a column called numerator, which corresponds to a public field on the fixture called numerator. There's also a column called denominator, which is tied to this public field, denominator. And the glue is automatic. Fit will look at this name and automatically associate it with that field. There's also a column called quotient, which is followed by a question mark. And that question mark is important. It means that you're asking a question, and it's going to execute a method. So there's a method here called quotient, which has the same name. So when Fit gets this table, it's going to load up this fixture, and for each row, it's going to set the numerator to 100, set the denominator to 4, and then call the quotient method, and check that value to make sure that it's the same value that was returned by the system. So that was column fixture. Row fixture is another one. It's great for testing sets of data. It's kind of analogous, so similar to performing a query on a database and checking each row to make sure it's there. It's very similar to column fixture. You can see a column called ID, and there's a field called ID. And there's a method, a column here called pay, which is associated to a method called pay. So what this one is going to do, in this case, is it's going to get all the employee pay records and check that employee 1 was paid $1,000 and employee 2 was paid $2,000. Just an example. And then there are action fixtures. And action fixtures are pretty easy to use, and lots of people like to use them. They simulate a user interface at some level. You can use them for lots of things, but they provide methods as though you were using a user interface. So imagine we had this window here. We have a text field, a label, and a count. So here we load up the count fixture, and then we check the counter. So we're checking this label to make sure that the value is 0. Right? And then we're pressing the count button. So you can press buttons with an action fixture. Every row here represents an action. After we press count, we'll check the counter again to make sure it's 6. We can also enter values. Enter is for something like a text field. So you can enter into the counter field the value 5, press count, and check the counter again to make it 6. It's just another example. You can kind of tie your fixtures to a user interface. You imagine if this was your UI, if you can think about that design. Let me go back a bit. Here we go. We saw that UI, that was one layer sitting on top of the system, and the tests are interacting with the system in the same way. So now that we know about Fit and some fixtures, let's go back to that example where we had to test the login feature. We know that we have to use BOC, build, operate, check. We need to know to provide concrete data as examples, and we need to avoid implementation details. How would we do this using Fit? So we might create a page. Login project, this is our first test. And notice we have some text in here. The text is helpful to describe what's going on, a little context. So it says, this is the first test, add some users to the system. And there's a table here with a title called Make Users Fixture. Now that doesn't look like the name of a Java class. Fitnesse tries to do some nice things to turn your text into a Java class name. There is actually a fixture called Make Users Fixture. And that will get loaded up. And there's 3 columns, username, password, and added. So we have rows, so username Micah, password Martin, and then we add it, so we're calling the add method, and it returns a Boolean to tell you whether the user was added or not. And we'll add another user called Luke, and his password is the force, and he was added to the system. Now, we'll try to log in with user credentials. Only registered users with matching passwords may be authenticated. We have a new fixture called Login, and it has similar columns, so username, password, and authenticated. So now we're going to provide a username and a password and ask if the user is authenticated. So username Micah, password Martin, authenticated should return yes. Username Micah, password Smith should return no, that's the wrong credentials. And we use Luke, the force, and that should be authenticated. So that's an example of how you might write that test using tables with fit. Any questions there? Yes, sir.
I didn't understand the difference between row and column fixtures. They are row fixtures or column fixtures?
Sorry, column fixture on which one?
Row and column.
Row column fixtures. So we'll go back just a moment. They look very similar. Column fixtures have these columns, and methods are executed. In row fixture, it's very similar, except we're not entering data anymore. We are going to get data from our objects and test it. And we are expecting 2 records to be returned here. If we were to have gotten 3 records, this table would turn red. It failed. If one of these records was missing, it would turn red and fail. If employee 2 was paid a different amount, again, this test would fail. So it's a row fixture is for pulling data out and testing all the data. Any more questions before I move on? Okay, so a guy named Rick Mugridge, he liked using Fit, and he decided to add a bunch of extensions. And he published something he called Fit Library. And Fit Library gives you a much larger tool set of fixtures. You know, Fit provides column, row, and action fixture. Fit Library provides much more. It has array fixtures for testing lists of data, set fixtures for unordered lists. It has support for images, support for tree structures. You can have nested tables in there. Perhaps the most popular and the most beneficial thing he added was something called a do fixture, which allows you to be more expressive in the way you put your tables together. You no longer need this first row, which is the title of your fixture, and you can type your test almost like sentences. So he's got the table split up. You can see multiple tables here. The first row is the name of a fixture, but it's the name of a do fixture. And the do fixture can take over your page and understand the rest of it. So he says connect user Sarah. User Sarah creates fit room. So he's implementing a chat client. He's got some text here. A check occupant fit 0. User Sarah enters unfit room. You can see that the test reads more like English. And lots of people like